Got a video here for you that has 2010 A/B test. This is from Form B, number 2. All right, let's see what we got here. I got a function for x values greater than 0. I know that g of 1 is 2. I got the derivative here, and I got the second derivative here. But I don't know what the g function is itself. I just know what its derivative and its second derivative are. All right. For part A, find all values of x in the interval from 0.12 to 1 at which the graph of g has a horizontal tangent line. So you want a horizontal tangent line. Well, that's a slope of 0, so that would be when g prime of x equals 0. Okay, so this is a calculator problem, so I'm going to go ahead and graph that derivative, and it's got a sign, it's got a trig function in it, so just make sure, double check I'm in radian mode, always good to check, and put that in there, sine of x plus 1 over x. Alright, I'm not just going to hit the graph button because this is has a very specific domain here, 0.12 to 1. And for the y values, I don't really care what the y values are so long as I can see where it crosses, where it's equal to 0. So I'll just go from, how about -1 to 1? Since this is a trig function, it seems like probably a good call. Alright, so how many places is this equal to 0? There's 2 of them, and that happens at x equals, find the zeros of this. So you can play the cursor game if you want to do your left bound and right bound. I'm not a big fan of that. Now I made the window, that was 0.12, so my left bound I'm just going to make 0.12, and then this went from 0.12 to 1. So I guess I would have to guess here. I'm going to try a right bound. Oh, you can move the cursor. So when I typed in 0.12, that moved the cursor to there, and then I just tapped a couple times, and that'll give me my right bound there. I was going to try 0.2, and I think that would have worked just fine. So that's x equals 0.163. Remember to round your calculator answers correctly to 3 decimal places. And the other one is here, so second calculate that other 0, and I guess the cursor's close enough, so I'll just play that game. So left bound, and then get to the other side of it at 0.359. Alright, that was pretty easy. Just finding where the derivative is equal to 0 with your calculator. Part B, on what subintervals of that same one that we just looked at is the graph of g concave down? There's 2 ways to do that. You could actually graph the second derivative and then look for where it's negative. You could also, if you remember, this is a graph of the derivative, and you can tell concavity from this because the slope of this is the second derivative, right? The slope of the slope. Looking at the derivative here, this is g prime, so the slope of this is the concavity. If this is going down, then it's concave down, like actually going down. If the derivative is decreasing, then concave down. If the derivative is increasing, then concave up, right? So let's see, it looks like there's a little, hard to tell what's going on there in the graph, right at the top. So I think I better find, if I want to know, well, let me do it both ways. So one way would be to find the maximum here and the minimum here, and then that's your interval of concave down because it's decreasing there. The other way would just be to go in here and graph the second derivative, which is 1 minus 1 over x squared times the cosine of x plus 1 over x. They could have made us do that, right? That's a very doable derivative with this, just a little bit of chain rule there. But for whatever reason, they decided to give it to us. Now, I don't want to get too confused here, so I'm going to go hover over the equal sign and turn that one off. I just got the cursor on the equal sign and then hit enter. That turns that one off. And then if I hit graph, now I will be only looking at the second derivative. Now that went way up there, so and way down here. So I think I better go to my window and how about like minus 10 to 10 and change the x values. Oh, that looked like what a good decision that was. Okay, so here am I in my same window from point? Yes, I am. I need to know when this is negative. And it looks like it is, because this is the graph of the second derivative. So when is it negative? It looks like, it's hard to tell what's going on here. So I think maybe I'm just going to go back to the window just to be sure. I'm going to make this equal to 0, and then I'm going to graph it again. Woo, there's some crazy stuff going on there. So I don't know where this, so this graph here is negative in here. And I think I better make sure to check where that crosses right there. So second, calculate, looking for the 0, and see, this is why I don't like the cursor game. You see where it's jumping up this line so fast. If I move to the left one more, it's off the screen. There, it's there. And then if I move to the right one more, that's somewhere down off the screen there. So my left bound, I could use this. And my right bound, just going to go one tick there. Okay, so that place where it crosses is actually in our interval. So this is concave down. The graph of the second derivative is negative from x equals, I'm going to do an interval like this, 0.129 to, got to find the other place it crosses there. Second, calculate, find that 0. And remember, the other way you could have done this is by looking at the graph. Okay, there's my left bound of the first derivative, and using the maximums and minimums of that. So that's 0.223. Right? And justify my answer because g double prime of x is negative on this interval. Okay? See? Write an equation for the tangent line to the graph of x at 0.3. Okay, that's easy to do. Should be, right? So to write the equation for the tangent line, I need a point and I need the slope. So the point I'm going to get by finding g of 0.3, and like, uh-oh, well, I don't have the g function, so how do I do that? Well, if you want to get g of 0.3 and you have the derivative here, then, excuse me, then fundamental theorem, right? So if I do the integral of g prime, that gets me back to the g function. But it gives us 2, right? It gives us the change in. So where should I go from where to where? Well, I know what g of 1 is. So I'm going to put that here. Why am I putting that up top? Because 0.3 is smaller than that. You could do it the other way around, just so long as you keep the order the right way, that whatever is on top comes first, right? Now this, since I have the g prime function and this is calculator active, I can do this with my calculator. G of 1 is 2, because they told me that. That's why I picked 1 as this other value. And then g of 0.3 is what I'm looking for, because that's the y coordinate I need for my tangent line. So that I'm going to get with my calculator. I'm just going to do it back on the home screen. I'm going to do the Math 9 integral from 0.3 to 1 of, I can type in the g prime if I want to, but as it happens, it's right there in y1, so if I wanted to, I could type right here. I could go to my variables menu, and I could go over to y values, and I can just put y1 there. Oops. And my x there. Okay, so that's that. So if I want g of 0.3, then algebra, I just move that over here, then subtract that. So 2 minus that is 1.546. Right? Okay, so now I have my point. G prime of 3 equals that. Now I just need the slope. I just need to know what is g prime of 0.3. And I have g prime right here, so I could do that on the home screen too. I just need to know what is the sine of 0.3 plus 1 over 0.3. That is negative 0.472. So I have everything I need. I just need to write the equation for the tangent line now. So that is going to be y minus my y coordinate is equal to the slope, and x minus the x coordinate. Well, there is my equation for my tangent line. And I got one more part here. Does the line tangent to the graph of g at 0.3 lie above or below the graph of g? When you are asked this question about whether tangent lines overestimate or underestimate, or how it's phrased here, does it lie above or below, this is a question about the second derivative. If you can picture, like, here's your tangent line, and there's the point that it's tangent to your function at, two things could be going on here. If the graph of g is concave down, then the tangent line is going to be above it. And if the graph of g is concave up, then the tangent line will be below it. Right? So it's really a question about what's the sign of the second derivative. So g double prime at 0.3, the place where we made our tangent line, just plug that in to the second derivative. 1 minus 1 over 0.3 squared times cosine of 1 plus 1 over 0.3. That is 3.742, which is greater than 0. All we really care about is the sign of that. So g double prime 0.3 is positive. So if it's positive, that's concave up. That means the tangent line is below. So tangent line is below the function.